Thank you very much for this opportunity. And I'm very happy to be here and speaking to all of you. The primary subject of my presentation today is going to be sustainability and building health and saving energy. And a quick introduction. I've had opportunity of studying in some of the best institutions around the world, in India, US, UK, and UAE, and having the opportunity of working with some of the best organizations around the world. So I'm going to give you, in the next 30 minutes, 30 years of my experience. And I hope that we can both learn together and see how we can make this world a better place for future generations. Now, we all understand about climate change. I'm not going to go into detail. We know that 1.5 degrees, yes, in terms of engineering is possible, but it requires the political will and the support of everybody in order to achieve this 1.5 degrees target. And if we don't, we know what's happening. Flash floods, extreme weather conditions, sea level rising, heat waves, forest fires, these are becoming more and more common. And I am speaking to you from Dubai, and 70% of our prime property is on the seashore. And the iconic world islands, the Palm, Dubai Islands, all this is going to get affected if the water level raises. We have never seen the kind of rains which we have seen last year. The entire city was flooded, and it had a huge impact on business. And heat waves in UAE become more and more common. We never used to use air conditioning between October, November, December, January earlier. But today, even during winter, we are using air conditioning, which is consuming more power and is affecting the lifestyle. So today, I'm going to be talking to you about air quality and breathing. So we started, each one of us, whoever is listening and whoever is not, started breathing the day they were born. And the day they stop breathing, they will either be buried or burned by their loved ones. So it's extremely important. And as per WHO, 7 million people die prematurely every year of air quality. Now, these are healthy people who are getting affected. And this is not only in poor third world countries, but even cities which call themselves smart cities, whether it is London, Shanghai, Singapore, Delhi, are getting affected by the poor air quality. Today, the extent is such that in Delhi, they actually have to shut down schools and offices because of air quality. So that's a situation which we are in today. Now we breathe about 11,000 liters of air, and we spend in UAE more than 90 to 95% of our time indoor. So the quality of the air we breathe definitely has an impact on our health, our well-being, our cognitive ability, and productivity. Now, this indoor air can be 3 to 5 times more polluted than the ambient air. This is a major challenge, and we are trying to solve this challenge. And we know from studies from Stanford, Harvard, and Munich that if we can improve air quality, the productivity of the people can improve by around 20%. Sickness and absenteeism can reduce by around 18%. The employee well-being increases by 30%, and this also increases retention. It's very clear that the air quality impact on financials is about 5 trillion globally. So we have a major challenge in terms of numbers, in terms of financials, and this is what we are trying to address. So what we do in Dubai is convert sick buildings into healthy buildings. And my company has pioneered its efforts on this. When you have poor air quality, it could cause sickness like asthma, allergies, pains, aches. Poor air conditioning could mean molds in ducts and the air which you breathe. So when you bring in air with humidity in UAE and in Dubai, we have 70 to 80% humidity almost throughout the year. The lowest humidity which we hit is around 60%. And when you bring it with 400 to 400 ppm carbon dioxide, then you get mold formation in the building's air conditioning. And this, in a high-rise building, if it is 20, 40, 80, 100 stories, is very difficult to clean, even with robots. So this air which we breathe has molds which is causing the sickness. And also, when the air conditioning is not properly designed, then it consumes a lot of energy. So what we have done is we have taken this challenge, which is affecting 7 million people globally, and tried to resolve it with a solution. Now, this is a schematic of a conventional air conditioning system in Dubai. And if you can note, the air comes through a unit called the FAHU, and this is fresh air handling unit. And this comes with carbon dioxide and with humidity and dust. The FAHU cleans the dust and to a certain extent removes the carbon dioxide. But predominantly, the molds formation happens because of the high levels of contaminants which enter into the duct. So at the FAHU level, the power consumption is very high. Similarly, the chiller. So chiller is another major challenge, and that is a place where huge amount of power is consumed in the building. And the FAHU keeps pumping air into the building. And what we noticed is more than 90% of the buildings in UAE and in Dubai are over-designed, because people look at, during the design stage, the maximum occupancy of the building at the highest ambient temperature. Now, these two aspects are mutually exclusive, we know by experience, because normally during summer, people go off and the occupancies in the building, whether it's office or residential, is low, and the ambient temperature is high. But in winter, when the air conditioning requirement is lesser, that's the time we have high occupancy in the building. What we have done is we have analyzed the behavior and the pattern of people coming into the building and found out when is the energy being consumed. We have also taken into account the ambient air quality to operate the FAHU. So I'm going to move to the next slide, which gives you a comparison of what we do with the old system and the proposed new system, which we have implemented successfully here in Dubai. So basically what we do is that we look at the internal carbon dioxide requirement and the air quality through sensors. We activate the FAHU based on the air quality of the building, based also on the ambient air quality. So we can also move into a predictive analysis that using the weather data when the ambient air quality will be good, and bring in air into the building when it is required by the building. And not only just air, we bring in air which is extremely pure. In terms of CO2 level, we bring in about 0 ppm CO2 level, 0 to 10 ppm max, and we take the air to about minus 70 to 100 degrees dew point to remove the humidity. So this is the system which we operate. We take the air, ambient air, and we compress the air to about 7 bar pressure. We take the air from inside the building, which is about 1000 ppm CO2 with the contaminants, compress it again to about 7 bar, cool the compressed air, and then extract the carbon dioxide with using the pressure swing adsorption technology. So the air which goes into the building, it goes at 0 ppm CO2, and then based on the requirement of the building, the air enters into the building. So this is the schematic of the process. We continuously measure real time the air quality. And when I say air quality, we measure CO2, VOC, humidity, temperature, PM 2.5, PM 10, all the parameters which you like to measure, we measure this. And based on the requirement of the building in terms of air quality, then we operate the units. So this is real-time data collection. And wherever the air quality falls down in terms of performance, we only supply clean, fresh, high-quality air in those locations. And the quality of the air which we supply is so good that it can be used in hospitals and operation rooms. So the air comes with very low concentration of carbon dioxide. All the contaminants are removed. We also use UV and a photocatalytic oxidation process to remove the pathogens from the air. And all the VOCs are also extracted from the air before it enters into the building. I have a short video, which I hope you can listen, which explains the process.
Maintaining indoor air quality is a huge expense in commercial buildings. Over time, contaminants like carbon dioxide, humidity, and VOCs build up inside the building. To address this, the typical HVAC system replaces all of the building's air every 1 to 2 hours to dilute them. This outside air adds 30 to 50% more load on HVAC systems. The result, massive wasted energy and oversized HVAC systems to deal with the load, which means higher first cost capital expense and greater ongoing energy and maintenance costs. Plus, outside air brings in its own pollutants, especially for buildings in cities or near highways.
Introducing Smart Air Handling Unit, SAHU. SAHU is the only solution that safely removes all indoor air contaminants through molecular cleaning,
which improves indoor air quality and reduces the need for outside air by 60 to 80%. This lowers required HVAC capacity for heating and cooling in capital expense, while reducing annual energy consumption by 20 to 30%, with peak savings of over 40% and much less outdoor pollution brought into the building. With the combination of energy savings and indoor air quality deployments can achieve 10 to 12 LEED points across indoor environmental quality innovation and energy credit.
So what we have done is we've installed this unit in one of our buildings here in Dubai, and we are installing it in multiple locations. And I have just shared in this the financial impact of having this unit. Now, I'm not considering the wellness impact, health impact, cognitive ability impact, purely based on electricity saving. We have achieved about 30% saving, peak about 42%. And this in Dubai works as a payback of about 3 years. So here you have a system which not only improves the indoor air quality, eliminates the sick building syndrome, reduces the heat island effect, converts buildings into carbon sinks, but also saves 30 to 40% of your electricity bill. And the kind of carbon impact which we have had with this unit is equal to planting about 330,000 trees on the roof. And this can be done within 3 years. Imagine 3 days. Imagine the amount of time required to plant 330,000 trees, water it, and maintain it. Here, we are in a position to install this on the roof of your building, capture the CO2 and use it in a greenhouse, which we have built in the building. So the carbon dioxide, which you capture, can be utilized in the greenhouse for performing hydroponic farming. Plus, if you notice these blue background which you have here behind the hydroponic farm, this is radiant cooling. So basically what we do is we run chilled water through these tubes to cool the area in the greenhouse. And when we run chilled water, the humidity condenses on this chilled water, and that water is again recirculated into the hydroponic farm. So we control not only the temperature, but water flow in the hydroponic farm, and we are able to produce leafy greens at a cost lesser than what you buy in supermarket. We call this beyond organic food supply. And today, in every building which we build here, we are introducing this hydroponic farm inside the building and also creating a small restaurant or a coffee shop with hydroponic farm. So we call this a greenhouse cafe in the building, and this has become a standard features of the buildings which we produce at Fakhruddin Properties. For doing this, we have achieved multiple awards. We've also got the coveted Product of the Year award from Green Building Council. From Climate Control, we have got the Best Innovation Award. The solution is patented, and we have the patent for it. The market potential is phenomenal. In terms of real estate, the global market potential is about 275 trillion, and we hope to see how we can make this commercially possible. With this solution, we are able to address 10 of the 17 United Nations SDGs. So the most important aspect is we are able to improve the health and wellness of the people in the buildings. We are able to improve their comfort. They feel a lot better when they are in the building. They save energy and also they save money. So my submission to all of you is to kindly look into this technology where we're using direct air carbon capture in the air conditioning system of the building to improve the indoor air quality and also save energy. So our submission is, let us all connect, collaborate to make the world greener, cleaner, and healthier for future generations. My contact details are available, and I'm happy to answer any question the group might have. Thank you.